So when it comes to compositing, the more AUV we provide, the better, because it's going to allow us to try different things. And what I have an AUV that I always create that is always helpful, that uses the dot product and the geometry normal. And what I use this for is to distinguish which face is pointing upward and which face is pointing downward and which face is pointing away. And this is a great way to fake skylighting or fake darkening the bottom of a geometry, and it can be very useful when you have RBD, for example, spinning, and you want to make sure that that is visible, the spinning. So you use this technique to change the top and bottom and the sides of the geometry to give it more contrast. And so this is a very useful AUV, and the way I do it is by using a dot product, get the geometry normal, so state vector surface normal, shading normal, and I'm going to compute the dot product between that and an up vector. I'm going to use this with a ramp. So this is going to give me -1 and 1. We need to fit this using a range node. So the range is going to be -1 to 1. And then I'm going to plug this into an RGB. And the RGB is going to be red, green, and blue. So just 3. And this way I can isolate individual segments of this geometry. And let's do this. Let's copy the AUV. I'm going to call this the dot. And I'm going to go to the geometry and delete a portion so it doesn't take too long to export. Or I think if we just export this as an AS file, it's going to be easier to work with. So yeah, let's do that instead. Let's go here, and instead of this, it's called 2 and RBD outer and hit render. And then we're gonna go to the RBD procedural, change this to 2, and make sure we are rendering this node instead. So let's go here, hit render, and we need to declare that AUV is called dot. And let's go to the dot. I don't see it. Let's hit render again and let me check the logs. Yep, it's working. So this is our AUV. Now everything that faces upward is going to be blue. Everything that is in the middle is going to be green. Everything that points downward is going to be red. So that's downward, that's green. You see everything is on the side, and then everything upward is going to be blue. And this is very useful. I use this channel all the time and have it as a default. Now, another thing that I was considering doing is, remember I wanted to get those cracks to eliminate, always eliminate. And what would be really cool is if we have a gradient, a ramp that starts per piece that starts black and goes to white, just a linear ramp, or maybe a radial ramp that we could use to create some kind of fake illumination. Okay, so this would be a ramp along the height of each geometry. So let's go to the object context and let's see how we can create this, something like this. Yeah, it's a bit slow, but we'll get there. So let's hide everything else. So what I want to do is I want to loop over, because I can use the geometry as it is, but it's not going to give me the result that I want with the rest attribute. I want to create a height attribute that represents the height of each geometry individually. So let's use a for each node, for each named primitive, and loop over each primitive. And what we need to do is we need to compare the position of these points compared to their a bounding box. So if we create a bounding box, and let's say we take this point, okay, and we compare it how far it is from the highest value in the bounding box. And if we take this point and compare it against the highest point in the bounding box, we can get a nice ramp between both of these. So that's what we're going to do. I'm going to create a point VOP. And let's dive inside. And I'm going to create a point bounding box. The point is going to be the first input, and this is going to give me the min and max. I don't care about all the vectors. I only care about the height. So vector to float, I need the height of the min, the height of the max. And then if we use this in a fit range, this is our height min, and this is our height max. So we have our bounding box. We now have access to each point knows its min, its min and maximum. So we just need to compare this against the top or bottom. So what I'm going to do is I'm going to take the height, the y position of each point, and I'm going to subtract the point position, the y point position with the maximum value or the minimum value. It doesn't really matter. So we just have a value. And then we're going to plug that between the min and max because this is going to normalize it. And if we now plug it into the color range, it should give us, oh, sorry, we're not going to, this is a vector, so we need to compute the length. And when we do this, so that should be, should be the same. So let's try this. So if we subtract this, okay, let's try the max. Let's go up and let's run over the entire geometry. So okay, so it is working. And it's comparing the geometry. Oh, I see. So few geometries are not matching this because I think the range is not working properly. So let's go back inside. Try. Yeah, I think this is better. So the min is going to be 0. And the max is going to be whatever the difference is between the two. Yeah, this is going to give me a normalized value between all the pieces. And I'm going to use this mask to obviously mask out the interior details. We're going to multiply it with that red and green, and we can use it to help enhance, you know, the whatever emission we're going to have using this ramp. So I'm going to bind export this as height. And because we're doing it at this level, it's going to work just fine. You know, we're doing it pre-deform, so it's going to be, it's not going to change after we sim. And I've already cached it. The one I have currently, the geometry is not as accurate as this one, but it's going to be fine. So that's the height. Let's go to the shader. And let's create this AV. I'm going to copy this node. And let's user data float. I'm going to import the height. And along the way, while doing this, I'm also going to create a few more things. So because this is a float, I don't want to store just a float in the red, green, blue channel. I want to include a few other things. So one of them is the occlusion. I'm going to create the ambient occlusion. I'm going to plug it into one of the AUVs, one of the channels. And I'm going to create a float to vector or float to RGB. And the first one is going to be occlusion. The second one is going to be my height. And we'll put in something else later. So let's go plug this in, and let's plug this in here and call it OCC for now, and we will remember that it has 2 channels. So if we go in the out context, type in occlusion and hit render. Now the render is going to be slower, obviously, because we're computing an extra occlusion pass in the shader, but it's not going to be a huge difference. So this is our occlusion. The red channel is the occlusion, and the green channel is the height. And it's working better on the bottom part because the values are not that great, but this is what we have right now. Okay, so the last thing I want to do, let me check something. So the last thing we can do is to create another AUV. This is pretty expensive and I didn't use it, but it can be helpful a lot. So a curvature, I'm gonna plug it into the blue channel. I'm gonna leave it as it is, and I don't need it to be RGB. I'm just gonna pick the red channel, and let's hit render. So this one is gonna help us identify the cracks in the geometry, and it can be really, really useful in destruction because it will help us isolate very interesting areas from the geometry. Yeah, so we get this, and if we mask it with the geometry, with the inside faces, we can get some nice glowy edges or whatever we need to do to enhance this geometry. We can brighten these edges if we wanted to. We can have more specular. And we can have it the other way. We can do concave as well. So this is going to give us the cracks. It's different than the occlusion. Okay, this visual is different than the occlusion. And this is the best way to get nice, if we wanted to have cracks emitting fire or lightning, this is the best way to do it. And if we mask it with the inside faces and isolate it, it's going to give us some really nice mask. And as the geometry separates, that glow will fade off. So it's based on the distance as well. But I'm not going to include it. It's just something that you guys can explore. So that's it really for the shading. I'm gonna do one last thing, which is the bump. So we want to add some bump to the geometry, but because it's a large scale scene, we have to be very careful with this value. So for now, I'm gonna use this, and I'm gonna plug it into the vector, geometry normal vector, and I'm gonna lower the value. You can see it already, it's very disturbed because the value is pretty high, and the easiest way to see it is to increase the specular and lower the roughness. This will tell us how strong our bump is. And if we set it to 0, you will see that the reflection is very clear, and as we increase it, it's gonna get very noisy. So that's how we can quickly tweak this value. And we'll set it to 0.3. And I don't need a lot of specular, and it's going to be rough anyway. And we're also going to include some diffuse roughness. This is very helpful when we have very rough surfaces. So something like that. Okay, so I'm going to copy this shader. I'm going to copy this shader, and I'm going to call it RBD ground or surrounding shading. I am going to assign it to the mountains and the coverage. And I'm going to include everything So let me change this to back so it includes the entire geometry, and I'm going to include all this. So ground coverage, main coverage or mounting coverage, mountain and ground, sorry, not the correct one, this one is. And I'm going to increase the resolution a bit, so 5. I'm going to increase the I'm going to increase the samples to 5, and I'm going to increase the resolution to 1440 by 960, and I'm going to keep everything the same, and let's hit render and see what we get. Thank you guys for watching, and see you in the next video. Bye bye.